Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, so let's get started on the homework for lesson 4.1.2. The M&Ms covered similarity and scale factor. And it says here, two figures are similar if they have the same shape, but not necessarily the same size. This is different from congruent figures, which would have the same shape and the same size. They're essentially identical twins if they're congruent to each other. But with similar, one of them would be bigger than the other, maybe, but the shape is the same, okay? So a scale factor compares the sizes of the parts of the scale drawing of an object and the actual sizes of the corresponding parts of the object itself. So when you think about a map and the city of Loomis, obviously your map, you want it to be proportional and look exactly like the city of Loomis if you were to take like a bird's eye view of it. But the map is going to be much smaller, obviously, than the actual town of Loomis. So basically what we got here are corresponding parts. And so if you take like this line segment here, it's going to correspond to this line segment here. And whatever you multiply times 10 to give you 25, that's going to be the scale factor that applies to everything between these two shapes. And so you can write these as ratios, like here's the 10 over 25, which simplifies down to 2/5, right? Wait, did I say multiply times 5? No, you multiply times 2.5, okay? Or if you're going in the other direction, you'd multiply it times 2/5, or 40%. This is 40% of that number. That is 2.5 times, or 250% of this number. But you just take any of the corresponding sides and write them as a ratio, and then simplify that ratio, and they're going to simplify down to the same thing, the same scale factor. And then the last one, these two are the corresponding sides, so you write that as a ratio, and it simplifies. So the thing is depending on which one is the original and which one is the new shape, or the copy, if you will, scale factor might get inverted. So if I put the 40 on the top and the 16 on the bottom, that means that the simplified ratio would be 5/2. So in essence, you can have two scale factors here if you really think about it. You can have one that makes it bigger, and the one that makes this bigger would be 5/2, which is the same as 2.5. Or you could have the scale factor that makes it smaller. If you were going from the bigger to smaller, then you would invert those two numbers, which is the same as 40%, or 0.4. So when I'm teaching about scale factor and similarity, I teach students, it just depends on where you're starting and which direction you're going as to which one of these two you're going to choose. But you got to find the ratio first. So take the corresponding sides, write them as a fraction, and simplify that fraction, and then decide which direction you're going in. Because let's say you didn't know this was 45. If I multiply 18 times our scale factor, that makes it bigger, it would be 18/1 times 5/2, and I'll do a little simplifying here to make that a 9, make that a 1, and so that means this side has to be 45, and it is. If I was going in the other direction, let's say we didn't know this guy, but we knew 40, and so now you're going to go from 40 to a smaller size, so we'll choose the smaller of the two ratios, the one that's less than 1, and say 40/1 times 2/5, and then if you simplify these guys by cross canceling, you get 8 times 2 equals 16. Well, sure enough, that's what this is. It's 16. So we'll work on this a lot. We'll continue going back and forth with scale factors, and there isn't one direction that you'll always go. So just think about this. If your number is getting bigger, you're going to multiply it times a scale factor that's greater than 1. If it's getting smaller, then you'll choose the scale factor that is less than 1. All right, what do we have here? Draw a diagram that could be represented by each of the following number expressions, and circle the terms and calculate the value of the expression. All right, so here you got 4. There's a line that's 1, 2, 3, 4 units, and then 2 that are 5. And then you got one that goes backwards, that's -3. So do I have these all locked in there? I probably do, yeah. So I'm not sure why I put those gaps in there. I shouldn't have. But basically, that's how you separate these into 3 terms. Here's the first term, there's the second term, and then this is the third term. So You can add them in any order you want once you've got them expanded out into addition, but otherwise you've got to do the multiplication first. So 2 5s is equal to 10, and now you know you're adding 4 to 10, not 4 to 2, right? And then this is -3, so 14 plus -3 is going to give you positive 11. Here you've got 4, there's your 4, plus 2 groupings of 5 minus 3, or 5 plus a -3. So first off, you'd want to figure out, all right, what do you get here when you go 5, then -3, that leaves you at 2, right? Then go another 5, which is 7, then take away 3, now you're at 4. So basically, this becomes 2 times 2, which is equal to 4, and 4 plus 4 is equal to 8. What fun. All right, while Mrs. Poppington was visiting the historic battleground at Gettysburg, she talked with landscapers who were replacing the sod in a park near the visitor center. The part of the lawn being replaced is shown over here. The diagram is not drawn to scale, but all the corners are right angles. So what do we need to do? Use your ruler to make a scale drawing. Let 1/4 inch equal 1 yard. All right, so you could do that. You know that this distance from here to here is going to be 10. This is going to be 3. That's going to be 4. That's going to be 6. And if that's 10 and that's 4, then this has to be 14. And if this is 3 and that's 6, then this one has to be 3. Okay? How many square yards of sod will be needed? Well, this would be a situation where you would maybe break this guy into 2 parts. So this is a 3 by 4 portion of the sod, which is 12. And this is a 3 by 14, which would be 42. So when you add those together, you get 54 square yards. Oh, by the way, here's your scale drawing. I don't know why. There you go. There's what the scale drawing should look like if we took the number of units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 6, and 4 and 10 make 14. So that's the way it should look. At $2.43 per square yard, how much will the sod cost? So we need to multiply $2.43 times 54, and when you do that, you get an answer of 131.22, because remember, 2 decimal places. And if you were going to estimate what your answer would be, 2 times 54 is 108, and 3 times 54 would be like 162. So your answer's got to be pretty close to halfway between those two numbers, since 2.43 is almost 2.5. All right, so the area will be surrounded by a temporary fence. The cost 25 cents per linear foot. How many feet will be needed? All right, so this is a perimeter problem where you just add up all the sides. So what do we have here? Let's get rid of what's in the middle there so it doesn't confuse the issue. I'm going to just go ahead and highlight different things. I know that 14 and 6 make 20. And 3, 3, and 4 make 10, so that's a total of 30, and then you add that in, and you get 40. So the perimeter of this is, wait, what's up, what is going on here? The area will be surrounded by a temporary fence. Are these yards? Are they yards? Oh, yes, those are yards. And so while it's 40 yards, since there's 3 feet in every yard, 40 yards times 3 give you a total of 120 feet. So now we're going to multiply 120 times 25 cents, and I'll use my calculator. No, I'm not doing that. Use my calculator for that. 120 times 0.2, nope, 0.25 equals $30, and then you add the 30 to the 131.22, and that should give you 161.22. So $161.22 will be the total cost of all the sod and of all the fencing. Oop, and there's another one, but we're not going to worry about that. Okay, so Troy has a number cube with the numbers 1 through 6 on it. Assuming each side is equally likely to appear right, because that's how a cube works, find the following probabilities. So what's the probability of getting a 2? Well, there's only 1 2 there, right? You can get a 1, a 2, a 3, a 4, a 5, or a 6. So since it has 6 sides, that's going to be your denominator, and only one of those is the number 2. So that's a 1 out of 6, 1/6 probability. Rolling an odd number, well, how many odd numbers are there? There's the 1, there's the 3, stop it. There's the 3, and there's the 5. So 3 out of 6 is the fraction, but that simplifies down to a 1/2 probability. Since half the numbers are odd, the other half are even. And then rolls a factor of 6. So remember, factors are numbers that you would multiply together to get an answer. So how could you multiply numbers together to give you 6 for a product? Well, you could multiply 1 and 6 will give you 6, and 2 and 3 will give you 6. But there's no way to multiply 4 times any of these numbers or 5 times any of these numbers to give you a 6. So you have a total of 4 out of the 6 possible sides are a factor of 6, which simplifies down to the fraction 2/3. And the diamond problems. Remember, we multiply the x's together to write the number on the top. You add the two numbers together to get the number on the bottom. So when you're dealing with a problem like this, we have to use some algebra or algebraic reasoning. Something plus 1.2 is going to give you an answer of negative 1.8. So if you recall, when you're adding two numbers together to get a sum, if you do the subtraction in the opposite order, you will get one of those numbers that you added in. So this number has to be something that's more negative than probably 1 or 2 because you're adding a positive to it, yet your sum is still negative. So when we subtract 1.2 from that, that's the same as adding a negative 1.2, and that ends up giving you a negative 3 for an answer. So negative 3 plus a positive 1.2 is going to give you negative 1.8. So these aren't integers, they're rational numbers, but the rules for adding positive and negative numbers remains the same for all kinds of numbers. So now that you know that's a negative 3, you multiply it times 1.2 and you get negative 3.6. Here, this question is asking you, what two numbers do you multiply together to give you negative 12 for an answer? When you add the two numbers, you get positive 4 for an answer. So if you think of all your possible combinations, you know 1 times 12 is 12, you know 2 times 6 is 12, and you know 3 times 4 is 12. But it's a negative 12, which means one of these has to be a negative. Since your sum is a positive number, you know that when you added the positive and the negative numbers together, the one that was the bigger number had to be the positive, right? You got more positives than negatives. So your possibilities are either negative 1 times 12, negative 2 times 6, or negative 3 times 4. When you add these two numbers together, you get 11 for your sum. When you add those two together, you get a 4 for your sum, and when you add those two numbers together, you get a 1 for your sum. This is the combination we're looking for. So these two numbers had to be a negative 2 and a positive 6, and it doesn't matter which order you wrote them in. If you put the 6 here and the negative 2 there, it doesn't make any difference. Okay, I'm not going to do C or D. If you have any questions about those, you can contact me and I'll work those out for you. And for our last problems, are these the last problems? Yes, those are the last problems. Being able to add, subtract, multiply, and divide. I know our last chapter test covered these concepts, but CPM is going to keep bringing them back into your homework because you need to continue reviewing them. Some of you, most of you did a great job on this test, but some of you are still struggling with these concepts a little bit. So the more you can practice them, the easier it gets. So once again, just go ahead and check these numbers, check the answers. If you need me to work out any of these because you don't understand how to get these answers, please contact me. I will work them out for you. All right, almost 13 and a half minutes. Let's go ahead and get on to our next activity. Take care, bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling